Hi guys, this is the solution of AP Calculus AB FRQ number 5 of 2024. This one is based on tangent lines and all. So let's read this one out. Consider a curve defined by the equation this, and it can be shown that the derivative is this. There is a point on the curve near 2 comma 4 which with x coordinate 3. Use the tangent line to the curve at 2 comma 4 to approximate the y coordinate of this point. Pretty straightforward. So I'm just gonna all they want from us is there is this curve and there's a point, let's call it 2 comma 4 here, and we have to draw a tangent line over here, and based on this tangent line we need to approximate the value of the function at x equal to 3. So at 3 there is some y which we do not know, which they want us to find. So what do we need to find the equation of a straight line? We need a slope and we need a point, right? That's what we do. A little bit of SAT here. We already have a nice and cozy point here. All we need is the derivative, and they are so kind that they have given us the derivative. All we need to do is plug in 2 comma 4 in this expression. So replacing x with 2 guys and y with 4. What do we have here? 2 times 2 is 4, 4 times 4 is 16, 16 plus 3 is 19. So the equation of the tangent line is going to look like y minus y1. Just to avoid confusion, this is y1 and this is x1. So y minus y1 is equal to m. What is m, guys? M is the slope. What is slope? Dy over dx, which is this. So is equal to negative 4 over 19 times x minus 2. Adding 4 both the sides. So I'm going to say that 4 minus 4 over 19 times x minus 2. But they need they're not really interested in the equation. They are interested in the y value at x equal to 3. So all we need to do is plug in this x as 3. So let's do that. If we plug in x as 3, so 4 minus 4 over 19, 3 minus 2. What is 3 minus 2, guys? 3 minus 2 is 1. So we are going to say that this is equal to 4 minus 4 over 19. Common denominator is 19. 19 times 4 is 76. 76 minus 4 is 72. So the answer is going to be 72 over 19. I don't think so this can be simplified further, can it? No. So that is the final answer for this question. The next one says that we're talking about B and C now, and I was talking to all my students. They were most of them had difficulty in answering question B because it was a little peculiar. Let's read this one out. Is the horizontal line y equal to 1 tangent to the curve? Give a reason for your answer. Okay. So what is a horizontal tangent again? Let's say I do not know how this looks like, although I know that this is an ellipse, but let's say I do not know. So what I will do is there is a function like this, and if I draw a horizontal line which just touches the function at some point, that's a horizontal tangent. And remember, what is the slope of horizontal tangent? Obviously the slope has to be 0. So if y equal to 1 is a tangent to the curve, that is pretty evident that the value of y coordinate at this point where it touches the curve should also be 1. And what is the x coordinate? That we can easily find, right? That we can easily find by plugging in this y equal to 1 over here. Let's do that. So if we plug in y equal to 1 in the equation, that's going to look like x square plus 3 times 1, which is 3, plus 2 times 1 square, which is just 2, is equal to 48. So x square plus 5 is 48. Subtracting 5 both the sides is 43. So x is plus minus root 43. So now we know that when y is equal to 1 on the function, x is either root 43 or minus root 43, which means that I have 2 points, root 43 comma 1 and minus root 43 comma 1. Now what we have to do is we have to find the derivative at these points, and if the derivative comes out to be 0, yes indeed, that is a horizontal tangent. But is the derivative 0? Well, I don't think so. We can work this out, of course, but dy over dx will be equal to -2 plus minus root 43. I'm just putting both of them together because I think you will understand. Plus minus root 43 over 3 plus 4 times y, which is just 1. So is this 0? Obviously it's not. It's -2 plus minus root 43 over 7, which is definitely not equal to 0. So if the dy over dx, so the slope is not 0, how can it be a horizontal tangent? So the answer is no, it is not a horizontal tangent. No way, this cannot be a horizontal tangent, and this is the justification. All right, let's move ahead to C. Now the curve intersects the positive x-axis at root 48. Yeah, okay, we just found that. The curve intersects the positive x-axis. It means that y is 0. So if you put y as 0, then x is root 48. Okay, is the line tangent to the curve at this point vertical? Okay. Now, when is the line vertical? When the derivative is undefined or does not exist. All we have to do is plug in this point over here and find out whether the derivative is undefined or not. So the derivative is given by -2 times root 48 over 3 plus 4 times 0, which is obviously very well defined. This is defined, guys. This is not equal to does not exist. Hence the answer to this question is also a no, that no, this is not a vertical tangent. Sorry, yeah, this tangent line is not vertical. Yeah, pretty straightforward. Let's move ahead. Let's try this question. This one says that for positive time, a particle is moving along another curve defined by this equation, and at the instant the particle is at 4, 2, the y-coordinate of the particle's position is decreasing, keyword decreasing, at the rate of 2 units per second. So what this means is dy over, not dx, dt, because it's with time, is 2. No, it's not 2, it's -2. Keep in mind, it's decreasing. So at that instant, what is the rate of the change of the x-coordinate? So what all they are asking us to find is dx over dt. And if I understand this correctly, this is a question on related rates, and related rates for which we need to use an implicit differentiation. Let's differentiate both the sides. The derivative of y cube is 3y squared times dy over dt. Remember, the derivative is with respect to time, like I said, related rates. Plus 2 comes out, and now I'm going to use the product rule. So x remains as it is, derivative of y is dy over dt, plus y remains as it is, derivative of x is dx over dt. 24 is a constant, the derivative of a constant is 0. We already know that the point at which we need to find this is 4, 2 as given in the question. So I'm going to replace y with 2. dy over dt is already given as -2. X is 4. dy over dt once again is -2. Y is 2. And dx over dt is unknown to us. So 2 square is 4, 4 times 3 is 12, 12 times 2 is 24, which is -24, plus 2 outside, 4 times 2 is 8, so -8, plus 2 times dx over dt is equal to 0. So -24 plus, not plus, minus 8 times 2 is 16, plus 4 dx over dt is equal to 0. 20, 30 and 40. So this is -40 plus 4 dx over dt is equal to 0. I think a little short in space here. I'm just gonna make some space over here. And this means that 40 goes over on the other side. So 4 dx over dt is equal to 40. And dividing both sides with 40, we have the, dividing both sides with 4, we have the answer as 10. And what's more important is 10 what? 10 units per second. They've not mentioned any feet or meters, right? No, I don't think so. It's just units. So it's units per second. That is the rate at which the x-coordinate of the function is changing with time. I hope this makes sense. Any questions, please post it down in the comment section, and I'll see you in the next video. Bye bye.